I remember that I often try to tell people if they're coming up with new ideas, what they want to do with remote sensing, and then I always kind of refer to say, just have a look in vegetation. We kind of know the properties that drive the signal, and this is well understood, and this is put into a model. I mean, I always tell people this, and I still think it's kind of true. But then I remember that you talked about, like, since you have been working with your crane, that some of the people have probably already seen in another video, this changed your perspective. But why? Can you explain this a bit?
I can explain, because if you look on the top of a canopy, you see things you have never seen if you just look from below, obviously. But even if you look from a more generalized scale with remote sensing, you don't see it. So you see branches, but the branches are not always the same. They have lichen, they have mosses, which change the spectral reflectance completely. You have a lot of different calamities, not always deadly to the tree, but just there. So you have illnesses to leaves, which sort of influence your signal quite strongly for a certain period. And then the tree sort of covers the whole thing or gets healthy again. And we do not know that much about it to really say, okay, we know a lot about the component. We know about leaf measurements of a healthy leaf, but this is not all. Yeah.
So would you say then that a lot of this, like what we always say, like it's an odd variability that you see? So you have pixels of what you're supposed to be the same species, but then these spectra look quite variable. They are not the same. So this is probably one reason why they are so different.
Yeah, but this is one reason, but it's not the only reason. So you know about the genetic diversity. So we have one pine is not as the same pine. So you have gradients all over the world, all over Europe, but you have even gradients on a smaller scale within one federal country, for example. So
yeah, I also remember this when we were thinking. I was as a student once. We were in a field, and there were like several forest stands, and they were all beech. But then you had like one forest stand with beech, which had all the leaves were green. And on the left side, there was another beech stand, and there was not a single leaf. And then our professor asked us, yeah, so what do you think? What is happening here? And we're like, yeah, probably dead, those trees, so that there are no leaves. And then like he laughed and said, no, it's just different genetics. So you have a completely different phenology. So this trees here will start 2 weeks later. And so, of course, you can say no leaves and leaves, it's easy. But then go 6 weeks later, that means these leaves are already 6 weeks old, while these are only 4 weeks old. And then you might have still quite a big difference in the chemistry of the leaves. And you have to deal with that. What was, for me, really quite new and also really quite interesting, and again, this goes back to your crane, and you said to me, which is also kind of new, I would say, is that each tree should really be considered an individual. So if you have 2 beech trees standing even next to each other, it doesn't mean that their leaf chemistry and the way they do their photosynthesis and so on is exactly the same. So can you maybe comment a bit on this, and also what this means for remote sensing in the end?
So for me, this was really new. So it was like we were approaching this crane site, which is mainly beech forest. There are other trees, but beeches are the majority. And we had healthy and not so healthy individuals. And we thought, okay, there is a clear difference between this tree and this tree and this tree. And we even selected them for a more intense measurement on them. But in the end, it was sometimes that we just measured certain spectral properties on that and certain pigments or biomarkers. And the biomarkers were completely different for individuals which looked visually both in the same direction of very healthy, for example. But then one of the individuals decided, I go for light. I have a huge shoot length in this year. I try to outcompete all the others in my size. And others said, okay, I'm a bit more afraid because I put everything in my leaf chemistry, to have phenos there to protect me against all the enemies, all the calamities, all the beetles who could come and, do me some harm. But they had the same sort of starting point. And I don't want to make them as humans, but they have definitely different individual strategies. So they're really individuals.